Hi, I will be walking you through how to create your own cryptocurrency. We're going to start by creating a GitHub repository, then we're going to fill it in with the source code, going to create a MetaMask wallet, send Ethereum testnet funds, which are free for us to use, and then we're going to migrate the code into the Remix IDE, we're going to compile it, deploy it to the JavaScript virtual machine, and then deploy it to the real world, which is Ethereum. We can also deploy it to the Binance Smart Chain or any others. And then we're going to verify the source code of the contract using Etherscan. We're going to interact with the contract by burning 50% of the token supply, and then we're going to register it in a decentralized exchange, and it's going to set the liquidity for it, so how much one token costs. And then finally, we're going to purchase some of the token using Ether. So the first step is to create a GitHub repository. GitHub essentially allows you to manage your code. If you ever make an error or a mistake in the future, then you can always backtrack it to a stable version. There's a lot of other features, such as collaborating on a repository. Multiple people can work on it. There's also branches and a lot of great things about GitHub. So if you don't already have an account, go to github.com and go ahead and create one. And then in your profile, you can click repositories. Click this new button. Let's name the repository, let's say crypto. And then for the description, let's say my cryptocurrency. We'll make it a public repository. And let's add in a README, and that's going to be the text that people see right when they click on the repository. And then let's also add in a license. Let's make it the MIT license. And then click Create Repository. Next, we're going to want to add code to the repository because right now it's empty. So here's a template that I'm providing. If you navigate there, it will look like this. So let's click raw, and this allows us to just do Control A, Control C. Go back to your repository that you just created. Click on add a new file, create new file. Let's name it contract.sol. You can name it anything as long as it has .sol at the end for the solidity file extension. And then in here, just do Control V. And then we need to create a commit, which is essentially just a change to the file. So it needs a comment. By default, it says create contract.sol. You can type anything here, but let's just go with the default of create contract.sol. And then don't change any of this. Let's just create new file. So now your repository has the file in it of contract.sol, and you have the source code for it. The next step is pretty simple. All you want to do is select a platform to use. So I'm proposing the Binance Smart Chain and then Ethereum. Ethereum is great, however the fees can get pretty expensive. So if you wanted to send like 1 penny from Alice to Bob, sometimes that fee can go up to $20 or more. It just depends on what time of day you're going to make the transaction and things like that. That's at the time of recording this. However, in the future this might change. So I'm proposing the Binance Smart Chain. This is very similar to Ethereum. However, the fees are very small, and it's a lot more lightweight, at least as of right now. Now that we have our smart contract safely stored inside of GitHub, we want to actually be able to use it. So we're going to use something called Remix. It's by Ethereum. You can get to it by going to remix.ethereum.org. And this is what it looks like. Let's create a new workspace. We'll just name it, I don't know, crypto. It's going to come with 3 smart contracts by default. We don't want these. They're not necessary, so we'll just delete them. And then let's select the contracts folder, and we're going to add a new file to it. We'll name it contract.sol. So here it is. And let's go back to our repository that we just created. Go to raw. Let's do Control A, Control C. So now we have the source code inside of our clipboard. We go here and paste it in, Control S. So now it's saved. And we can see that there's a compiler error right here. So this is because the version of the compiler is actually wrong. So let's go. So we can see it right here. We defined it to be 0.8.0. So let's go here. Let's set it to 0.8.0. We don't need any of these other parameters. They're optional. And we just do compile. And now we can see that it did compile. The green check mark means that it did compile. So that's a good sign. But yeah, now it's inside of Remix. So we use GitHub and Remix. It may seem kind of redundant to use two different places to store the source code, but Remix IDE is stored inside of local storage, meaning that right as soon as you clear the browser storage, all of this is going to be removed. So to counter that, we use GitHub as sort of like a permanent storage place for the code. And then if you ever make any changes to the source code, we can then do the same exact process, move it back to Remix or back to GitHub, and then compile it, make sure it compiles, and then we can go from there. Before I proceed on showing how to deploy your contract, I'm going to first explain how to actually understand the Solidity contract. So it's built in the Solidity programming language, and there's documentation for it, so you can look into that and understand it. But for ours specifically, we have 3 contracts, and a contract kind of acts as like a class, if any of you are familiar with Java. But yeah, so we have the ERC20 interface, the safe math, and then the coin. The coin is an ERC20 interface and safe math, and this basically just says it's going to adopt all of these functions. Now, because ERC20 interface is abstract, it's going to require us to have all of these functions. These are just headers, so they actually need a definition. You need to like add source code into it. You can't do it here, but you can do it here. And what is ERC20? Well, Ethereum wanted a standard for tokens. They wanted to say, you know, if you're going to have a token, we want applications to be able to interact with it all the same way, consistently. And so in order for that to happen, we need every single contract that is a token to have these functions and these events. And so an event is kind of like something you can sign up for to be alerted whenever like a transaction happens. And then these functions for interacting, like how do you send money? Well, you can transfer it, and I'll show later on how to actually how to use these functions when they're actually deployed. But yeah, so you have to have these in order for it to be a token. And then safe math, it's more of just a tool. It's a way that we can ensure that no errors occur. So like, what about divide by 0? You know, if you're doing something inside your contract, well, you could divide by 0, and that's going to cause an error. But if you have safe math, this is essentially saying, you know, if b is greater than 0, then we can proceed. But if it's not, it's going to actually revert the transaction that we're making. So yeah, it's kind of interesting. We want to use safe math wherever we can, just because it ensures that no matter what happens, the math will be successful. You know, you can't multiply by 0, you can't divide by 0, things like that. And then here's the contract. Notice that there are these public variables, and public is also assigned on the functions. There's also private, such as this one, underscore transfer. This was defined by me, and it is not accessible or visible to any other contract or anything outside of it. So people interacting with the contract, they can use these public functions, but they cannot use the private ones. So it's kind of an interesting concept. And then what we're doing is we're just filling in the abstract ERC20 interface standard. So we're saying it must have total supply, it must be balance of, allowance, transfer, approve, transfer from. It must have a definition for all of these, and that's exactly what we're doing. So this is kind of like the core token that you can have, but you can add a lot of functions on top of this code to make it do whatever you want. So the next step is kind of cool. We're actually going to deploy the contract. So let's actually let's change the name real quick. I don't know. Let's name it Bitcoin. Let's name it Bitcoin 2, BTC 2. Yeah, and just make sure that it compiles. And if this ever does not compile, then you need to make sure it does before you can proceed. But now we're going to go to this tab, and there's a lot of different ways that we can deploy the contract. We're going to just use the JavaScript VM first. And so essentially what this is it's like a blockchain that's already inside the browser. It's just like stored inside of local storage of the browser. And so if you were to like clear the cache or anything, then it all gets removed. It's a very temporary thing, but it does allow you to deploy it. So let's just do that. We can choose an account. So there's already like a ton of different accounts that we can choose from, and this is just so that we can do a lot of experimenting. They're all given 100 Ether, and that's plenty. So we'll just go with all the default settings, and then just click. We'll first make sure that it's the right one. So contract.sol, and then just click deploy. So that was really fast. You can see right here there's the screen check, which means it was successful. It is stored, or it is successfully inside of the JavaScript VM. And then you can actually interact with it now. You can see all of our functions that we've used. So here are all of the functions we've defined, and they're actually inside of the deployed contract right here. And so, if you wanted to do something, you can click the buttons and you can actually interact with them, like type something and then try to approve it or not approve it. And this one errored because this is not a valid address. But yeah, you can test all of this stuff now, and you can interact with the contract like you would any other real world contract that exists. So we have just shown that our smart contract, is deployable to the JavaScript VM. We have been able to interact with the functions, and all of these functions are the public variables and functions inside of our smart contract. So let's see. So like we say that there's the public name Bitcoin 2, then you can find it here, public name Bitcoin 2. And this is accessible by everyone that interacts with the smart contract in the real world. Well, right now it's in the JavaScript virtual machine, but when we deploy it. And same goes for the functions. So the total supply is a function, and so that would be, here's the variable total supply, and then here's the function total supply. Yeah. Okay, so let's deploy this to the real world. So to do that, we need to first set up a wallet. There's plenty of wallets that we can use. There's Exodus, there's Trust Wallet, there's Coinbase Wallet, MetaMask. We're going to use MetaMask, and you go to metamask.io, go download now. I'm using Firefox, but you can use whatever browser you want. It takes you to the web store. We'll just add it. Okay, so I'm going to show you how to interact with this. A wallet is basically, it's like it's an application that stores your public and private keys in a way that you can interact with web applications on the web that want to transfer funds from A to B. So like a donate button. If you wanted to donate like Bitcoin somewhere or Ethereum, then you can you click a donate button. It'll connect to your Trust Wallet or your MetaMask or whatever wallet application you're using, and then you can accept the application inside of MetaMask, and the money will send. So it's kind of interesting. If you already have a MetaMask, you can import the secret recovery phrase or create a wallet. Let's do no, and then go to password. And then, yeah, you can watch this video if you like. Basically, there is a secret backup phrase. It's just a sequence of words. Since this is a tutorial, I'm making all of this publicly seen, but yeah, you would want to hide this, because this, if anybody gains access or to these words, then this is like the password to your money. They can just enter it into any into MetaMask and then or any other wallet and gain the funds that you have in there. So I'm not actually going to store funds in mine, which is why I'm making it available. But yeah, you want to write it down, and then it's going to ask you to confirm them. So I'm just going to put it here for the sake of a tutorial. You would want to write it down, and then you want to verify it. Enjoy. Over chat. There we go. Okay, so there we go. It is created. You've just created your MetaMask account. This is what it looks like. It shows that we have 0 Ethereum, and this is on the Ethereum mainnet. You can also access it just by clicking this icon here, Ethereum mainnet. We actually don't want to go to the mainnet. The mainnet is for real money. Let's use a testnet, because testnet is like toy money, but it's to the real world. So yeah, I mean, so we'll have money here. And how do we get money here? Well, there's actually something called faucets. So if you just Google like Robston faucet, you can click any of these, paste the wallet. So you saw I just click this and it copies it. Make sure it's the Robston test network. You can do it inside of here as well. Robston testnet, copy. Yeah, you paste it in here, and this is your public address right here. So if anyone has access to it, they can't take your funds, but they can give you funds. They can send money. So because it's a test net, all of Ethereum is free inside of here. So just say, send me test ether. Okay. And then let's see. I'm going to pause until this transaction becomes successful. It's the next day, and as you can see, the money has been received. So now you are ready to deploy your contract to the real world. Now that our MetaMask wallet has enough funds in it, we can actually deploy it to the real world. So let's follow the same exact step. Instead of using the JavaScript VM, let's use injected Web3. And immediately you can see MetaMask opens up, trying to connect to our web application. So we'll click the one that has the funds. Next, connect. And now you can see that the account is the one from MetaMask. So select that, leave everything default just like previously, and then make sure that you're selecting the correct contract. Publish to IPFS, you don't need that. That's more for like contracts that require file uploads and images and things. We don't need that in that case, so let's just click deploy. Now, unlike the JavaScript VM, it actually creates a transaction. So the transaction, it does cost money, but this is fake money. It's 0.001027 ETH. So since we have the funds for that, just click confirm. And then it is being created currently. There we go. So the green check means that it was successful. And here you can see you can actually interact with it. Now, okay, so if you click this, then you can get the information about it. And the information that we want is the transaction hash. So just copy that. We could actually verify it in the real world. So go to Robston Etherscan. So this is so Etherscan is like, it's the monitor platform for the blockchain. So you can look up any kind of account or address or transaction or block. So I'm just going to paste in the transaction. So there's proof that we have deployed it, and here you can see it notices that it is a Bitcoin 2 BTC2 contract. Let's go to the contract, and now you can see that it actually is all here. The contract is deployed to the Robston testnet. Before we do anything else, we need to verify the contract inside of Etherscan. So go to the contract, make sure it does say contract. We're going to go to contract, and it says, are you the creator? Verify and publish your contract source code today. So we'll click that. For the compiler type, we only have one file, so do single file. Compiler version is 0.8.0. And the source type, let's do MIT license. Now, if you did any optimization, so inside of the IDE, by default, it has no optimization. If you did that, then you can check it right there. But this, we want to give the source code here so that we can prove that the contract is valid. So we'll just do Control-A, Control-C, copy the source code, paste it right there. Make sure you do not modify anything, otherwise this will not work. And then for the arguments, we'll just leave it alone because it fills itself automatically. And then verify and publish. And then wait a little bit. There we go. So it was successful. Here's all the parameters. Here's the ABI. So that this is essentially like the different variables, how you can interact with the contract. So there we go. Now if we go back to the contract, then we can see now the contract source code is verified. Now that we have verified our contract, let's try interacting with it. So here's our contract page on Etherscan. It says contract. There's also a token page, which is because our contract follows the ERC20 interface. And so we can just click that, see that it's a token. So here we will list all of the recent transactions will be listed here, and then for the holders, we're currently the only holder, but as people start purchasing our coin, then it will keep increasing. And then for here, we can read the contract and write the contract. These are very, very similar to the remix functions that we saw earlier. We can interact with them. But let's try actually writing to a contract. Let's try burning some money. Now, to begin, first of all, we need to make sure that that we are the owner, because inside of MetaMask, we don't see that we own that. So copy the contract address, then go to here, make sure you're in the Assets tab and click Add Token, paste it in. You'll see it automatically fills in BTC2 with 18 decimal places. Click Next, Add Token. And there we are. We are the owner of the contract. We have the 2 billion. So let's first get the address. I'm just going to send it. Let's start with this. So this is 0x with 40 zeros after it. Back at the token, let's create a contract. Create a interact with the contract. So go to write contract, and then connect to Web3. Click MetaMask. Now we've connected MetaMask to the page, and so we can try sending money. Let's go. Let's transfer some. Let's transfer. I don't know. Like let's do 1,000. Let's actually do half of the token supply. So there's 1 billion. Click right. It's going to pop up the transaction dialog, and you can see it does cost a little bit. Click confirm, and I'm going to pause it because this sometimes takes some time, but it is pending. And it looks like it was just successful. So if we go to our transaction on Etherscan, we can see it was successful. So we have sent the funds, so we can go to holders. And now that was actually a issue because there are 18 decimal places, and I'll explain that in the next video why that happened. But yeah, we just created a transaction and we sent some of the funds to this account. The problem with the last video, and I'm glad this actually happened because this is something I was meaning to bring up, is that we meant to send 1 billion BTC2. However, we've talked previously about how every single variable inside of our smart contract is an integer. there are no like floats or decimals or doubles or anything like that. And so how we can fix this, like if you want to send a fraction of a BTC2, you can fix that by multiplying every single value inside of the token by 10 to the 18. So that would be 18 zeros after every number. And so if you were to think 1 with 18 zeros, that would actually be equivalent to 1 BTC2. So we can fix this. Like I meant to send 50% of the token supply to this 0x000 address. We can fix this by, we want to send this much. We already sent this much. And then we want to send the rest of it. So that would be 18 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then the rest of it is the amount that we want to send. We want to send 1 billion. And then we're going to accommodate for our previous transaction. So that would be this value, this amount. So let's do that again. Paste that in. Click write. Confirm. And then we're going to wait for it to finish. I'll pause the video while I wait. Okay, it was successful now. So if we go back to our token, refresh the page, we'll go to holders, and now you can see that it is an equal supply. So 0x00000 holds 50% of the token supply, while we hold the other 50%. Now this says 100% on both of these, because this is actually, this 0x0000 is known as the burn address. This is where, if you want to burn some coins, you're going to put them here. And what this essentially means is it's going to take them out of the market. There is no owner to this address. And so this is the reason why we would do this is because if there's a lot of holders in this coin or this token, then we're going to want to make it, we're going to want to have deflation. And deflation occurs when the token gets rarer and rarer, so it gains value. And what this essentially does is if you burn the token, 50% of burning the token, then that's going to increase the value of everyone else's supply. Now, this is kind of a bad example because I'm the only owner right now, but if there were other owners, this would actually happen. And that's why burning is considered a very positive thing for currencies. If you burn some tokens, then it's going to benefit everybody else. So this is great. We've been able to interact with the contract and send money to a burn address. However, what if we want other people to be able to do the same? Well, because we're the owners of the money, we can transfer money. However, if someone doesn't even own any of this BTC2 to begin with, then they can't really do this. So the solution is we need to connect this to a decentralized exchange, also known as a DEX, a DEX. So it's also worth noting, just real quick, that when we interact with a contract like this is actually the only scenario where we will need to use the 18 decimal places, because other applications that will be sending and receiving BTC2 are going to automatically accommodate for the 18 decimal places. So whenever you do it directly, then you have to apply the 18 zeros after every transaction. However, yeah, other applications do this automatically. So to begin, let's use Uniswap. Uniswap is it's the most popular decentralized exchange for Bitcoin smart contract tokens. And so what we'll do is we'll say use Uniswap, and we're going to have to create it because Uniswap doesn't actually know about our coin. So we're going to have to go to pool, and then we're going to need the contract address. Just copy that. Oops. And we're going to have to create a pool. Now, the interface for Uniswap changes a lot, so just keep that in mind. What we're just doing, we're creating a way for Uniswap to know our token. So just create pool, and then I've already connected my wallet, but you'll have to do that for connecting MetaMask. So it's saying select a pair, and for this we need to paste our address. It says Bitcoin2, and this is the first time that it has ever been set up with an exchange, so we're going to have to do some extra stuff because we're the creator. So First of all, we want to select a fee. We'll just do the best for most pairs fee, 0.3%, which might change. And then the starting price. So we can do it in ETH or Bitcoin. Let's set it to, I don't know, 1 million. So let's say 1 ETH is equal to 1 million BTC2. And then for this, we need to set a minimum price and a maximum price. So let's just do the same thing. 1 million and 1 million. And you can see it does change. Let's do -6% and plus 0.6%. And so now we have a minimum and maximum price that it will sell for. And then we actually have to supply it with money. So because this is all fake money, it doesn't really matter. But let's supply it with 0.5 Ethereum. And that's going to buy us this much BTC2. So let's do approve. And then we will confirm. We're essentially adding liquidity to our token. So now there's money backing the token, 0.5 Ethereum. And it was just approved. We'll look at it on the Explorer. Here's the transaction. Yeah, so there we go. So we have now, okay, we set it up. Let's do add. We're going to add it. Click add. And then this is when it actually sends the money. 0.5 plus the transaction fee. Just do confirm. Transaction was submitted. Look at that transaction as well. So 0.5 Ether. And we've now just added our coin to the Uniswap pool. So now we can transact with it. So this is pretty cool now. We've set up our exchange. We've set up our token on the exchange. We can set a price. So let's actually try buying some. If somebody wants to buy some of the coin, they can now convert between any of these coins, any of these tokens, into ours, into BTC2. So let's say ETH. Let's I don't know. Let's buy 0.1 ETH worth of BTC2. We can do swap. Confirm swap. It's going to ask for the transaction confirmation. Just do confirm. Transaction submitted. So there we go. That's basically how it works. Now we have our coin or our token. We've deployed it to the Ethereum network, and now we've set it up on an exchange. We've given it a price, and people can now purchase it. Now it's also worth noting this is all inside the Ropsten testnet. However, doing this on the mainnet is the exact same procedure. And if we go back to the Etherscan for our token, we can go to transfers. Here's all of the transactions we've made, and here's all the holders. And this one right here is the Uniswap holder. So they own 0.2% of the supply. That's pretty small, actually. We can always give them more, but it's how many tokens they have to work with. So whenever you want to buy some Uniswap tokens or some BTC tokens on Uniswap, you purchase them from this address, this contract, and that's what a decentralized exchange is. It's an exchange that's driven by a smart contract. So that's pretty much it. We've done a lot. Hopefully everyone was able to follow along. And yeah, so you made it this far. So here's an overview of everything that we've done. We created a GitHub repository, filled it with our source code, created a MetaMask wallet, and we sent Ethereum testnet funds to it for free. Then we migrated our code into the Remix IDE, compiled it, deployed it to the JavaScript virtual machine, and then deployed it to the real world, which is Ethereum. It's also worth noting Binance has the exact same procedure, only instead of Etherscan, we're going to use BSC-scan, and instead of Uniswap, we're going to use PancakeSwap. And then we verified the source code of the contract within Etherscan. BSC scan has a very similar way to do this. And then we interacted with the contract by burning 50% of the token supply. Then we registered it inside the decentralized exchange, Uniswap, and then we set the liquidity of how much one token costs. And then finally, we purchased some using Ether.